Hey folks, Mr. Bullock here, and here's some more AP Stats style multiple choice questions. So I'll try and get a few more of these videos out before you take your test. Don't forget, if you go to playlist as well, I have the whole year up there, so you can cherry pick out which lessons you think you want to get caught up on. Anyway, so I'm finding a lot more of you guys that are watching these are not my students, which I think is kind of cool too. Anyway. So you play tennis regularly with a friend, and from past experience, you believe that the outcome of each match is independent. For any given match, you have a probability of 0.6 of winning. So the probability that you win the next two matches is, well, since it's independent, you guys, and then so you're doing two, then you just multiply those individual probabilities. So 0.6 times 0.6, and I get choice B. Okay, somewhere, you guys, I picked these out of a different resource, so this resource had lowercase letters, and I didn't catch it till after the fact. So most, in fact, your multiple choices on your AP test will be uppercase letters. So we'll get through about half of these with lowercase, and the other ones will be uppercase. Okay. So if the probability of A is 0.24 and B is 0.52 and A and B are independent, what's the probability of A or B? Okay, remember that formula? We add these together and then we subtract off the intersection of the two. Okay, so the probability of A plus the probability of B minus the probability where they intersect. Do you guys remember when we talked about this, or when your teacher talked about this, you had two overlapping circles where they overlapped in the middle. Here's A, here's B. And then so we add the probability of A and we add the probability of B, and that middle part gets counted twice. So we take it off once right there. So the probability of A or B anyway. So we get choice C on that one if we do our math right. Okay. So in a particular game, a fair die is tossed. If the number of spots showing is either a 4 or a 5, you win $1. If the number of spots showing is a 6, you win $4. And if the number of spots showing is a 1, 2, or 3, you win nothing. So let X be the amount that you win. The expected value then is, okay, so this is just the average of the winnings, you guys. So for 1, 2, or 3, I win nothing. So 0 plus 0 plus 0. For 4 or 5, I win $1, so plus 1, and then plus 4, and then the average of those, you add them up and divide by 6, and you get $1. So choice B. Okay, so suppose that X is a continuous random variable taking values between 0 and 2 and having the following density curve below, the density function, density curve. Remember, density curves, the area is always equal to 1. Okay, and let's just kind of check real quick. The area of this right triangle is 1/2 base times height. That does equal 1. 2 times 1 and half of that. Okay, so this equals 1. So what's the probability that X is in between 1 and 2? Okay, well that would be this little right triangle right here. So 1/2 base times height, so it's going to be 1/2 1 times 1/2, because this is 1/2 right here. Okay, and I get 1/4, which is 0.25. Choice C. Okay, which of the following are true statements? By the law of large numbers, the mean of a random variable will get closer and closer to a specific value. Well, the law of large numbers, what that does, you guys, is it makes it closer to the mean, but your mean, it makes your samples closer to the mean, but your mean is an unchanged number. Your mean of your data is an unchanged number. So it's not that one, you guys. The law of large numbers gets our samples closer and closer to the mean, but the mean is an unchanged number. Okay, the standard deviation of a random variable is never negative. Let's see, and the standard deviation of a random variable is 0 only if the random variable takes on a lone single value. Okay. Well, the mean is, like I said, the mean is unchanging. It's a fixed number. So the law of large numbers gives the average of observed X values, and they tend to be closer and closer to the mean after more and more repetitions. The standard deviation is positive. Let's see, it's always positive, and the only way that we can get a variance of 0, which means your standard deviation of 0, is if, remember the variance formula, each number minus the mean squared divided by the probability. So we'll do this more a little bit. So each number minus the mean squared divided by the probability, and we add them all up, so that would be the variance. So the standard deviation is the square root of that. So the only way this is going to be 0 is if X equals your mean. So if each X value equals your mean. So that makes this one true, that makes this one true, but this one's not true because of the little glitch. Man, it sure smells like it's going to be true, but the mean is never going to change. It's always a fixed number. The law of large numbers just makes our samples get closer to our mean right there. So it was, what choice was that? I'm sorry, you guys. So choice C on that one, because 1 isn't true, you guys. So that takes out this one, it takes out this one, it takes out this one. But this one looks good right there. So choice C. Okay, a television game show has 3 payoffs with the following probabilities. Okay, so the payoff is 0 with 70%, 500 with 25%, and 5,000 with 5%. What are the mean and standard deviations of the payoff? Okay, well, remember, the mean is the payoff times the probability, plus this payoff times the probability, plus this payoff times the probability. And then the standard deviation, you guys, is this formula right here. Each number minus the mean squared times the probability. And then we square root all of that stuff. So I did that right here, you guys. So the mean is, like I said, each number times the probability. And so it ends up being in the sum of that, so it's 375. So the variance is going to be each number minus the mean squared times the probability. The next number minus the mean squared times the probability, and so on. So I get this big number, so square root it, and my standard deviation is that. So I get choice B on that. Okay? All right. Which of the following are true statements? Tests of significance, your hypothesis tests, are designed to measure the strength of evidence against your null hypotheses. Okay, well, that's true. A well-planned test of significance should result in a statement either that the null hypothesis is true or that it is false. Well, no, that's not true. We're testing to see, if it's probable to be true or false, but not if it. You can't test if it is true or false. And the null hypothesis is one-sided. And expressed using either less than or greater than if there is interest in deviations in only one direction. Well, that sounds true, except it's the alternative hypothesis. Your null hypothesis is that it equals whatever the mean is, you guys, or whatever you're trying to do. Okay, your alternative is the one-sided less than or greater than. So the only one that's true, you guys, is choice 1 right there. So that explains what I just said right there. And so none of them are choice 1, so it's none of the above gives the complete set of true responses. The only one that's true is 1. Okay, so none of them are true. So 2 confidence intervals estimates from the same sample size are given right here. Okay, so we need to check out these confidence intervals. Can you see that this confidence interval is smaller than this confidence interval right here? So one estimate is at the 95% level and the other one's at the 99% level. So which one is which? So which one? So basically, you guys, the narrow interval corresponds to the lower confidence interval. So I get choice A on this one because this is my smaller confidence interval, so it's going to get me a 95% confidence level. Okay, if I want to get a bigger confidence interval, then it's going to be a bigger interval right there. Okay, so if I want to get less and less and less, it's going to make it smaller anyway. So choice A on that one. Does that make sense? I hope so. So when leaving from school on an overcast morning, you make a judgment on the null hypotheses. The weather will remain dry. What would the results be of a type 1 and type 2 error? Okay, I covered type 1 and type 2 error from a different lesson. Actually, it's one of these. I just did it yesterday, I think. So type 1 error is rejecting the null hypotheses when it was in fact true. Type 2 error is not rejecting the null hypotheses when it was in fact false. So say you got a sample and it made one of these errors. It made it enough to make a type 1 or type 2 error right there. Okay, so given this, so when leaving for school on an overcast morning, you make a judgment of the null hypotheses. Okay, so my null hypothesis is the weather's going to remain dry. So to make a type 1 error is we reject the null hypotheses and conclude that it will remain wet. Okay, so type 1 error is the null hypothesis is correct that the weather is dry, but you reject it. So thus needlessly carrying around an umbrella. So that would be right there. And so this second part right here is type 2 is when the null is wrong, so it's going to rain, but you fail to reject it, which means you get drenched because you didn't bring an umbrella. So you got to cipher through all that wording right there, and you find out that choice B is that one. All right, one more, you guys. Which of the following distributions has a mean of 60 and a standard deviation of 4? Okay, a mean of 60 means that the middle number is 60. So it's not choice A or choice B. So it's either C, D, or E, okay? And if you didn't know what to do after this, you got to guess. You have to guess, you guys. The AP does not penalize you for guessing wrong. So never leave them blank, you guys. Even if you're running out of time, start guessing. And I do have a guessing video. So check that out, you guys. So anyway, let's see, a mean of 60 and standard deviation of 4. Okay, well, if it's standard deviation of 4, remember your 30 or your 95, the empirical rule, you guys. The empirical rule implies that 99% of the data, 99.7% of data, falls within 3 standard deviations. So 3 standard deviations means if one standard deviation is 4, then 3 of them is going to be 12. 12 to the left and 12 to the right. So it's going to be choice E, because if I go 12 down from here, that's only 8 on this one and only 8 on this one. So the 99.7 empirical rule says that 3 standard deviations are going to be this way, 3 standard deviations are going to be that way. So I get choice E. Okay? Hey, if you're finding these videos are helping you guys, just click like. That would be cool, you guys. And if you haven't done so already, subscribe, and it'll tell you when I upload some more. Okay? And I have your calculus uploaded and everything else. Take care, you guys.